ANSBL is a trick to determine the bonds in lone pairs for a Lewis dot diagram. The first part of ANSBL is the letter A. The letter A stands for the actual number of valence electrons. To find this number, you have to figure out how many of each element are in the compound, and then you have to figure out how many valence electrons each element has. The second part of ANSBL is the letter N. The letter N stands for the number of valence electrons needed. This means that you have to figure out how many valence electrons each element needs to feel happy. The third part of ANSBL is the letter S, which stands for the number of shared electrons. To find this, you take the value you have for N minus the value that you have for A. The fourth part of ANSBL is the letter B, which stands for the number of bonds. To find this value, you take the value of S and you divide that by number 2. Last but not least, you have the letter L, which stands for the number of lone pairs. To find this value, you take the value of A minus the value of S and divide that all by 2. The tip I have for you deals with the letter N. The tip is that most elements need 8 electrons, but hydrogen, lithium, beryllium, and boron only need 2 electrons. Keep this stored away because it'll help you out. When drawing Lewis dot diagrams, you deal with many compounds. The first compound I'm going to teach you about are regular compounds. These include CH4, H2O, NH3, SF6, and many more. The first step is to determine the actual number of valence electrons in the compound. So you start off and you see that there's 1 carbon and there's 4 hydrogens. Carbon has 4 valence electrons while hydrogen has 1 valence electrons. When you add these two values together, you get 8. The purpose of N is to figure out how many valence electrons are needed in the compound. So for carbon, it needs 8 valence electrons, and hydrogen only needs 2 valence electrons. See, I told you that tip would come in handy. So there's 1 of carbon and there are 4 of hydrogen. And so when you add those two values together, you get 16. As I said before, to get the value of S, you take the value of N, which is 16, minus the value of A, which is 8. The resulting answer is 8. To find the value of B, you take the value of S, which is 8, and you divide that by 2. When you divide 8 by 2, you get 4. To find the number of lone pairs, you take the value of A, which is 8, minus the value of S, which is 8, and you divide that by 2. You get 0 divided by 2, which is 0, which means that there are no lone pairs. Now that we've figured out all the values using ANSBL, we can now draw the compound. So what you do is you start out with putting carbon in the middle. Next, you draw 4 bonds, which you figured out using ANSBL. Then you place 1 hydrogen with each bond. So that means since there are 4 bonds, there should be 4 hydrogens drawn in your picture. The next compounds that I'm going to teach you are compounds with anions. And these include CO3 with -2 charge, SO4 with -2 charge, and many more. In this compound, there's 1 nitrogen, which has 5 valence electrons, and there are 3 oxygens, which have 6 valence electrons. What you do with the -1 charge is you do the exact opposite. So since it's -1, you add 1, and the total value of this is 24. In this compound, both nitrogen and oxygen need 8 valence electrons. There's 1 nitrogen and there are 3 oxygens, so when you add this together, you get the value of 32. For S, you take the value of N, which is 32, minus the value of A, which is 24, and the answer you get is 8. For B, to determine the number of bonds, you take the value of S, which is 8, and divide that by 2. The answer you get is 4, so that means there are 4 bonds. Lastly, you have to determine the number of lone pairs in this compound. To find this, you take the value of A, which is 24, minus the value of S, which is 8, and divide that by 2. You get 8 lone pairs. Now you have to draw 4 bonds around the nitrogen, but instead of putting 1 on each side, you have to double up on one side because there are only 3 oxygens, not 4. Next, you put an oxygen with each of the bonds. Next, you fill up the drawing with the valence electrons. There were 8 lone pairs, so you must put 8 in the drawing. You may have thought you were done at the step before, but there's one more major thing that you need to do. You need to put brackets on either side of the diagram and put a -1 charge on the outside. This shows that it's an anion. Since I already did compounds with anions, I might as well do compounds with cations. These include NH4 plus 1, PCl4 plus 1, etc. There is 1 nitrogen in this compound and 4 hydrogens. And nitrogen has 5 valence electrons while hydrogen has 1. And also, since it's a +1 charge, you have to subtract 1. And when you do this, you get 8. As I said before, there's 1 nitrogen and there are 4 hydrogens in this compound. The nitrogen needs 8 valence electrons while hydrogen only needs 2. These added together are 16. N minus A equals 8 because 16 minus 8 equals 8. There are 4 bonds in this compound because you take S, which is 8, and you divide that by 2. There are 0 lone pairs in this compound because 8 minus 8 divided by 2 is 0. Next, you put the 4 bonds around the nitrogen, 1 on each side. Then you put a hydrogen with each one of the bonds. Like you did with the anions, you must put brackets and the charge around the compound. So for this compound, you put brackets and a +1 charge. The second to last type that I'm going to teach you are compounds with resonance, and these include SO3, NO3 with -1 charge, and O3. In this compound, there's 1 sulfur, which has 6 valence electrons, and there are 3 oxygens, which have also 6 valence electrons, and when you add those two together, you get 24. Both sulfur and oxygen need 8 valence electrons, and there's 1 sulfur and there are 3 oxygens, so when you add that together, you get a total of 32. For S, you take N minus A, so you take 32 minus 24, which is 8. To find the bond, you divide 8 by 2, and you get an answer of 4, so that means there are 4 bonds in this compound. To find the number of lone pairs, you take 24 minus 8 and divide that by 2. The total number of lone pairs in this compound is 8. Then you put an oxygen with each bond. Next, you fill in the 8 lone pairs around the oxygens. This double-headed arrow you put in between the compounds when you have resonance. This is the second way that you can draw SO3. This arrow means that there is still one more compound that can be written a different way. This is the third and final way you can draw SO3. The last type of Lewis dot diagram that I'm going to show you is where you trade a bond for a lone pair, or you trade a lone pair for a bond. In this compound, there's 1 carbon with 4 valence electrons. There are 3 oxygens with 6 valence electrons, and because there's a -2 charge, you add 2. This all adds up to 24. Both carbon and oxygen need 8 valence electrons, and there's 1 carbon and there are 3 oxygens, so this adds up to 32. 32 minus 24 equals 8. There are 4 bonds in this compound because 8 divided by 2 is 4. You take 24 minus 8 and divide that by 2 to get a total of 8 lone pairs. Because there are only 3 oxygens, you only need 3 bonds. So you take 1 bond and add it to the lone pair, so you have a total of 9 lone pairs. This allows you to have 3 lone pairs for each oxygen. Draw 3 bonds around carbon. Put an oxygen at each bond. Put 3 lone pairs around each oxygen so that you have a total of 9. Don't forget to put the bracket in the -2 charge around the compound.